Good morning, everyone, and we welcome you to IITD for the 7-day winter school. That is the ACM Winter School on Full Stack Networking. I hope you guys have settled down because most of you have arrived yesterday and having your hostel accommodations, and I hope all is going well. So, very good morning. We are here, so myself, Rinku Shah, I'm an assistant professor here at IIT Delhi. We have, yeah.
Good morning, everyone. I am Arani Bhattacharya, an assistant professor at IIT Delhi.
Hi everyone, I'm Priyanka Naik. I'm a research scientist at IBM Research India.
Yeah, so we'll be here to help you out throughout your journey for this next 7 days. And just to give you a rough idea of what is going on here. So we have received participation from almost all parts of India. We have 37 plus participants. So you can see that it's kind of a diverse group here. So try to network as much as possible and build some solid collaborations in the future. Also, we are happy to say that we also have geographic diversity of the speakers around the world. And just to have a ice-breaking session here, because we don't want a one-way traffic. It's a school, it's not a conference or a seminar, so let's have a two-way discussion. So just to break the ice, we have a few questions for you guys. And please feel free to raise your hands or just stand up and talk. So just one first question. How many of you guys have attended any other ACM school prior to this? Anyone? Okay, good. Then I think this is the first experience and I hope we do our best. Then the other question is that where did you hear about this school from? So I can see people are shying right away. I hope that this doesn't happen for the next 7 days.
We are not proceeding unless we have one answer for this question.
I'm sure you must have heard from somewhere. That's the reason you guys are here. So, yes. Sorry? College faculty. Good. Student chapters. Yes. LinkedIn. Great. ACM mailing list. Yes. Good. Okay. Great. Okay. Now this is a very important question because this will decide whether we'll be successfully delivering what you guys want or not. So among the events that we have scheduled, so you're aware that we have tutorial sessions, hands-on sessions, invited talks, and conceptual sessions related to networking. So when you looked at the school schedule or the school topics, what is the most important thing that you're looking forward to? Sorry? Hands-on sessions. Okay, good. Okay, I hope that everybody has not just come for hands-on session. Otherwise, the first half of the school you can go and sleep in your hostel rooms. Anything else?
Invited talks.
Invited talks, yeah, great.
Networking stacks and theoretical concepts.
Theoretical concepts, great, yeah. Okay, so we have major people for hands-on, and if that's the case, then please keep your setups ready, whatever we've given you. And anytime anything is going fast or going slow or something is not followed, feel free to reach out to us, to volunteers. Please do that. So we are wearing green badges, volunteers will be wearing yellow badges. So please feel free to reach out to us. And okay, I think this last question is almost similar to the previous one, that what do you hope to gain at the end of the school. So I think mostly people are talking about hands-on, invited talks, some concepts. And we hope that we deliver what they are interested in. Okay, so let me give you a big picture of what we are going to do for the next 7 days, including today. Can anybody give me some example of a cloud application that you use on day-to-day basis? So currently my slides are running on Google Slides. So I have not prepared the slides on my local machine. The slides are prepared as well as they are running currently on the Google Slide platform. So that is again a cloud service. So that is one example of a cloud service that we use in day-to-day life. There are multiple such examples. One of the examples is of this kind where latency is not that very important. There are other examples where you must have seen that there are traffic cameras in smart cities that are already installed in multiple cities. They're already installed. They do some surveillance and monitoring. So there are applications of the sort where we do traffic surveillance. There, the data rates are important. Sometimes the latency is important. There'll be some autonomous driving applications. Currently, they're not running in India, but the future goals exist where you want like latency sensitive, highly reliable kind of communication. So there are applications of this sort. There are applications that run in the industry, which do exist today also. That is, some robotic arms are processing and preparing some manufacturing equipments, specifically in the mechanical industries. So we have these all sort of applications, and they have different requirements. And how do they run? So, for example, applications which for your day-to-day life, you use Zoom, Netflix, you use Uber, you use Ola. All these applications basically are nothing but cloud services. And depending on the requirements of the application, the services may run either closer to the client or it may run far off from the client. So they're generally a split distribution of services within the edge and the cloud. So considering this big example, and we are talking about full stack networking, so what are we going to learn with respect to this use case? When I talk about the cloud, typically what exactly is present in a cloud or a data center? So you have this rack of servers. So you see these are nothing but multiple servers, and all these servers in one rack will be connected to a top of the rack switch, and this top of the rack switch will be connected to other top of the rack switches, and so on. And finally, a star network with multiple layers will be created, and all these servers will be interconnected with each other. So this is how a typical data center setup looks like. You can see I have a very huge rack here and smaller rack here, just to indicate the capabilities of the edge and the clouds are different. In this particular setup, we know that 90%, more than 90% of these servers run Linux operating system. So your day one is basically to understand the internals of Linux networking, how the Linux network stack works, what are the performance overheads, what are the solutions to optimize these overheads. So that's the day one's talk, the conceptual talk. And in the hands-on session, what you'll be doing is you'll be understanding basic Linux commands, and we'll set up some simple network functions like a firewall, a rate limiter, and a load balancer using a simple Linux kernel. So we will be learning that for the day one. Now, once we are aware of how Linux works, the next question is, because we want those applications to be running, so where these applications cannot just directly run on the server, because there will be multiple tenants who will be using these servers, and we don't want anybody to have access to anybody else's data. So another concept that you'll be studying is virtualization, where how do we isolate the resources, how do we provide fairness among the resources and security and stuff like that. So there are everybody is definitely aware of the concept of virtualization. So in the older days, we had something called as virtual machines, and which you already have installed also for your hands-on session for the day one. But today, the data centers have almost moved from VMs to containers. So during your day two, you will learn some of the virtualization concepts and how do you launch containers, deploy your application over using containers. And for that, we'll be using the platform that is Docker. So we'll use Docker containers and see how do we deploy cloud applications using Docker containers on these data center kind of environment. But we'll not be using data centers, but will emulate, I mean, we will just do it on our local setup here. So that's day 2. Now, once we have learned how to deploy applications on these containers, the next question is, these containers, typically today what happens is, a single application does not run on one container. This application is broken down into smaller services for reasons that you've already studied in your object-oriented programming, that we would want highly, what? Object-oriented mein kya padha hai? Monolithic applications are not a good to go thing. What you want to do is divide your application into smaller services or smaller functions, which are modular, yes, which are modular, which are highly cohesive. So you would want to divide your single monolithic application into smaller modular services. So this concept that you will be talking about is called as the, so we call them as microservices. So a typical cloud application is nothing but a set of microservices that talk to each other. So the next question is, once we've understood deploying the containers, the next question is that now these containers will run your different services, and these services will have to talk to each other. So how do we have, so you can see this is a software switch here. So it's kind of, you have to have a software switch where these containers talk to each other. So you already know that configuring the switches is not a very easy job. So you can do this human configuration by configuring, and to be honest, there are thousands of microservices that run for a singular application. So it is really not humanly possible to configure all of this by hand. So the next question is, can we automate this job? So to do that, we have Kubernetes. So Kubernetes helps in multiple aspects. One of them is managing the networking between these containers, then automatically scaling your applications, so on and so forth. You'll study more in details during the session. So your day 2, partial day 2 and day 3 is about how Docker networking works using Kubernetes. So once this is done, what next? So we've seen how to deploy applications, how to communicate between microservices. Now, there would be similar kind of scenario. I've shown it in the cloud, but a similar scenario also exists on the edge. So there will be this series of microservices talking to each other. The problem here, or the difference here, is you talked about these robotic applications. You talked about autonomous driving. You talked about traffic surveillance. The problem there is you have to ensure that the latency is within limits. The other property is we need high reliability. Failure is not tolerable at all. If this is the scenario, and if your cloud applications fail, something was wrong, you need a strong monitoring capability, and that monitoring capability should not utilize a lot of resources, because edge does not have a lot of resources. So how do you have a low resource consumption based monitoring and a reliable solution? So for monitoring, we will be talking about something called as eBPF. So you must have seen this in the title. So day 4 is about eBPF for how do we perform monitoring of applications within the cloud. Now, once this is done, the next step is, we've talked about all networking components. How do we write applications on these containers? So we have to communicate between these microservices using remote procedure calls, RPCs. There will be message-based communication using Kafka. So day 7 is about how do we have application layer networking done? Because till now, whatever networking we were talking about was at layer 2. Everybody is aware of layer 2, layer 3. So till now, all networking that we're talking about was about layer 2 and layer 3. But we need networking even at application layer. So day 5 partially and 6 partially is about how do we providing tools to provide networking at the application layer. So by now you must be thinking that, okay, the cloud part is done. We've talked about how do we write applications at the application layer, how do we do networking. The next question is, we have completely not talked about the edge side. That is the most important thing, because the client communicates with the edge, with the cloud. So how about the edge side. So on the edge side, you see that these devices would be communicating using wireless mechanism or a wired mechanism with your edge cloud and your data centers. So they are, again, the environment there is quite non-deterministic in nature. There will be errors, the data rates are always changing, non-deterministic and stuff like that. So what are the problems at the edge? And so that will be discussed, and there will be solutions of something like if there are different multiple paths to reach the edge, how do we leverage those multiple paths for a better solution? So day 7 is about edge application networking.